Okay, so we are going to be discussing chapter 6 right now. So, chapter 6 is going to talk about the environment and change over time. And just so you know, my dog is with me right now, and she's kind of a naughty little puppy. So, if you hear strange noises in the background, it's probably the dog. All right, so the first thing we need to talk about is the fossil record. So the fossil record is made up of all of the fossils ever discovered on Earth. So every single fossil that's ever been discovered is part of this fossil record. And what the fossil record does is provides evidence that species have changed over time. So scientists can look at different species over time and see by their fossils how they have changed. The only thing about the fossil record, though, is that it's incomplete. So it doesn't show every single organism that has ever lived, because not every single organism that has ever lived actually creates a fossil. So we just have a small fraction of all of the organisms ever in existence in the fossil record. So it's always being added to as scientists find new fossils also. So how do fossils form? There's several ways that we're going to mention for how fossils can form. So the first one is called mineralization. And in mineralization, what happens is the body of the organism gets buried under mud or sand or other sediments in a stream. And over time, minerals in the water are going to replace the organism's original material and harden into rock. So all of that original material that was in that organism that got buried under the mud or the sand or in this wet environment, that's all going to get replaced by rock. So these minerals replace the original material. The second kind is called carbonization. In carbonization, what happens is you have a dead organism and it's going to get compressed over time. So that means it's going to be squeezed really, really, really hard. And all of that pressure is actually going to push out the liquid and the gas, leaving only the carbon outline. So it's kind of like if you were to, if you had a balloon, right, that had a hole in it. And if you pushed on that balloon, and squished it and squished it and squished it, you're going to push out all of the gas that's in the balloon, right? All of the air that's in the balloon is going to get squished out, and all you're going to get left with is just the balloon itself. No air left in the balloon. Same idea here with this carbonization. All of the air, all of that gas, all of that liquid gets pushed out, so all that's left is just the carbon outline of the organism. The third kind are called molds and casts. Molds and casts happen when you have the shell or bone or something of a dead organism, and it leaves an impression or an imprint in the mud or the sand. And then other sediments fill in that imprint and harden. So the mold is the imprint, so that impression of that organism, of the shell or the bone or whatever. The cast is made when the sediments fill in the mold and harden. Oh, there's that dog barking at me. Come on, Coda. She's being naughty, so she's tied up to me. The next kind are trace fossils. A trace fossil is actually preserved evidence of the activity of the organism. So it might be tracks that the organism left, or maybe poop that the organism dropped, or something like that. So it's evidence that the organism was there, but it's not actually the organism itself. And then finally, the last one is original material. And so what happens with original material is the preserved original material is what you have. That's the actual fossil. So an example of that would be like an insect in amber. So the insect is preserved, it's still that original insect, but it's hardened in this piece of amber, which then is the fossil. Okay, we also have to figure out how old fossils are. Um, and scientists date fossils in two ways. So the first one is called relative age dating. So in relative age dating, what the scientists are doing is trying to figure out the relative order in which the rock layers were deposited, and then comparing the fossils or the rocks to other things, just to figure out if it's older or younger. So they're estimating the relative age of one rock or fossil compared to another rock or fossil. So they're trying to figure out if something is older or younger or same age even as another thing. So they're not actually trying to figure out exactly how old something is. They're not looking for an exact number. They're just trying to figure out if it's older or younger. When we're doing relative age dating, the older rock and older fossils are the things that end up on the bottom. The newer rock and the newer fossils are going to be the things that end up on the top. You can kind of think of this like our recycling bin in the classroom. If we were to leave that for a couple months and not have it taken out, if we were to dig deep down into the bottom of the recycling bin, what would we find? Right? We would find the old papers, the stuff from a couple months ago. That would be deep down in the bottom of our recycling bin. If we were to look at the top of the recycling bin, we're probably going to find things that we put in there maybe yesterday or things that are really recent. So the way this relative age dating thing works is kind of the same way. The older stuff ends up on the bottom, the newer stuff on the top, because as you add to the pile, you're going to end up with the newer and newer and newer stuff added on the top. The other kind of age dating is called absolute age dating. And in absolute age dating, what happens is that scientists use what we call radioactive decay. So they're looking at things called half-lives and how elements break down. And they're using that radioactive decay to figure out the absolute age in years. So they're really looking for a number when they do absolute age dating, not like relative age dating. So relative, they're just trying to figure out if something's older or younger. In absolute, they're looking for an exact age. So once we figure out the ages of the fossils, we can talk more about this geologic time scale. And a geologic time scale is a chart that divides Earth's history into different time units. So you can see a picture of it over here on the side. So it's really kind of like the timeline of Earth's history. So eons are the longest units. Earth's history has 4 eons, and you can see here on this chart, they're just showing you one of the eons. Actually 2, Precambrian and Phanerozoic. So that's 2 of the 4 eons showing here on this chart. Eons then get divided into eras, and you can see that here on the chart. So we've got the Paleozoic, the Mesozoic, and the Cenozoic era. Eras get divided into periods. So the Cenozoic has the Quaternary, the Neogene, the Paleogene. The Mesozoic has the Cretaceous, Jurassic, Triassic, so on and so forth. And then periods get divided into epochs, but we're not going to worry too much about those. So we've got eons, which are divided into eras, which are divided into periods. Now, over time, we have things that go extinct. And extinction happens when the very last individual organisms of a species dies. There have been 5 mass extinctions in the latest eon. So in this Phanerozoic eon, we have had 5 mass extinctions. And you can think about that, like when the dinosaurs died, that would be a mass extinction. I read somewhere not too long ago that we are currently going through what scientists believe to be one of the biggest mass extinctions since probably the dinosaurs, which is kind of a scary thing. But extinctions can be caused by, well, extinctions are generally caused by an environmental change. So something in the environment changes, so these things can't survive anymore. So again, think about the dinosaurs. They believed that there was that whole meteor that hit Earth that shot up dust, which blocked out the sun, which caused plants to die, which caused plant eaters to die, which caused things that ate the plant eaters to die, and so on and so forth. So that would be a big environmental change that led to a mass extinction. Mass extinctions can be sudden, like that. They believe that the extinction of the dinosaurs was pretty fast. It happened pretty quickly comparative to time. Or they can be really gradual. The mass extinction that I read about, where they're saying that mammals are going through, or that we are going through one of the biggest mass extinctions ever right now, it's a gradual mass extinction. So it's not happening quickly, but happening slowly over time. And so that's going to end section 1 of our chapter.